thank goodness for the mid-morning session versus the mid-afternoon session, because I think I would have really had a challenge to stay energized and active. Thank you, Mark, for the lead-in. Little bit about me. I'm located in Charleston, West Virginia area. Been there right out of college. Grew up in Western Pennsylvania, but I've been in West Virginia a lot longer than growing up in Western Pennsylvania. So whenever I go home, all my friends from grade school and high school and college, they tell me I talk like a hick. So I guess that's now home. Dow Chemical has 3 facilities in the Charleston area, and it's referred to as West Virginia Operations, WVO. We have a technology park in the town of South Charleston. South Charleston is a little business community that is located directly west of Charleston, West Virginia, Charleston being the capital of the state of West Virginia. And the reason it is south, it is on the south side of the river, so even though it's west of Charleston. The technology park has engineering, licensing, and pilot plant. The tech park is actually owned and operated by the state of West Virginia as part of the Higher Education Authority. We have a manufacturing site also in the city of South Charleston. 3 Dow manufacturing facilities within the site, as well as a Covestro production unit, and Dow provides utilities and infrastructure to support those operations. And then we also have a manufacturing site west of those, roughly 7 to 10 miles, Institute, West Virginia. There are 6 Dow operating facilities at that site, support several different Dow businesses, as well as utility and infrastructure support. West Virginia Operations was the original research and development headquarters, as well as engineering for Union Carbide Corporation. And Union Carbide was obtained by Dow as part of the 2001 merger. My pay stub still says Union Carbide on it, but I'm still a Dow employee. Dow Chemical is headquartered in Midland and has recently merged with Dow Corning and DuPont. And we're not going to talk any about those activities. Unless you want to buy me a beer tonight, we'll talk a little bit more about that. Interesting premise to this session, Buncefield, and I'm not going to go into a lot of information about it. Mark covered it in general, but again, very large storage tank facility had overflowed, resulted in a vapor cloud. The vapor cloud found an ignition source, explosion occurred, multiple fuel tanks involved in the fire. Fortunately, as mentioned before, there were no fatalities. It took 5 days to extinguish. Human effects may have been even greater had the event not occurred early on a Sunday. So a little bit of luck involved. The HSE has a fantastic report on the details of Buncefield. So if you really want to get into a lot of the details and story behind it, there's the reference. You could Google HSE, and it has links to the information. Also, the slide presentations are made available to the attendees, and there's some supplemental information that I added at the end of the presentation, more of the details of the actual instrumentation. So feel free to peruse that. Pretty ominous picture, that's for sure. So some of the findings, again, is kind of a premise into the 4 questions, because for the most part, the company felt that they were, fairly well protected with the instrumentation that they had. It had an automatic tank gauging system. measured the rising level of the fuel, displayed it on the screen, and at the incident, the day of the incident, it basically, the information was shown a flat line. It meant that the level was not rising. And as a result of the failure of the instrumentation, there were 3 alarms associated with it. Well, because the instrumentation was compromised, now the levels aren't going to sound any alarms. The other thing was, again, talking a little bit about the culture, their standard practice was to work to the alarm level. So it was no longer looked at as potential protection. It was more a matter of, okay, yeah, we got it as high as we need to go, so we're ready to move on with the rest of the operation. So in this particular case, there was no alert to the fact that the tank was at risk for overfilling, and nobody went out to physically check it to see what happened. There was redundant instrumentation as well as a shutdown. It had an independent high-level switch, and it was set higher than the alarm points that they were using from the other one. And this was intended to stop the filling automatically, close the valves on the pipeline, as well as sound an audible alarm should the tank reach an unintended high level. Well, that independent high-level switch also failed to register the rising level. So the final alarm didn't sound, the automatic shutdown wasn't activated, and the tank level reached the capacity and started spilling out of the vents up at the roof. Vapor cloud was noticed by members of the public off-site and by the tanker drivers waiting to fill the vehicles. They alerted the employees. The fire alarm button was pressed, sounded the alarm, and started the fire water pump. And the explosion occurred almost immediately. And their premise or their guess is that as a result of the fire water pump starting, it created a spark and set off the explosion. So if you have a vapor cloud that is explosive, it will find an ignition source. The switch that was put in for the high-level trip, it was installed in the summer. It was designed and manufactured and supplied by an engineering company. They designed the switch so that some of the functionality could be routinely tested. It's nice to be able to test these things on a periodic basis. Unfortunately, the way it was designed, installed, and maintained, it gave the technicians a false sense of security. Those who installed and operated the switch didn't fully understand the way it worked or the crucial role it played, and it involved a padlock. And the switch was effectively left inoperable after the last test because the technician doing the test didn't fully understand how the switch was designed. Even though it was periodically tested, none of the staff was aware of the need for putting the padlock back on it so that the test lever was held in the correct position. So basically, after they tested it and thought it was operational, it was essentially bypassed. On the automatic tank gauging system, they had a servo gauge. It was stuck. And when they went back and looked at the records, this wasn't the first time it happened. It had stuck 14 times between August, when they returned the tank to service after maintenance, and the day of the incident. 14 times. All right, that's kind of a bad actor. Sometimes the sticking was logged as a fault by supervisors, other times it was not. Failure to have an effective fault logging process and a lack of maintenance regime that could reliably respond to the faults. Those were 2 identified important root causes that were associated with managerial and organizational failures. All right. Some other shortcomings. There was only one visual display screen for the data. that was being provided by the automatic tank gauging system. All right, and there were multiple tanks that were showing, or multiple tanks that were involved, but only one tank could be viewed at a time. So it wasn't as effective a design as an HMI. On the night of the incident, the display that was related to that particular tank was at or near the back of a stack of 4 other tank display windows. Only one computer was provided, no backup. Supervisors relied heavily on the automatic tank gauge system to control the tank filling, so having no backup for the critical process was inadvisable, obviously. And on the redundant emergency shutdown, tank mimics on the screen showed a red shutdown button. It was designed to close the tank side valves. Unbeknown to a number of supervisors, this was not working and had never been fitted into the system. Had it worked, it may have provided a useful emergency procedure, although it may have taken several minutes for the valves to close. The issue is indicative of poor management control, where supervisors did not appreciate the redundancy of the stop button and never tested it. Okay. These were some identified management system failures. Safety management system focused too closely on personal safety and lacked any real depth knowledge about control of major process hazards, specifically as it related to primary containment. Process safety controls on safety critical operations were not maintained. Senior managers didn't apply effective control. Effective auditing systems weren't in place. Poor communication on shift handover, lack of engineering expertise, failure to implement management of change process. All right, so list of the ensuing fines and court-ordered costs. One of the authorities in the realm of process safety in industry made a comment. I'm not sure if it's attributed to Trevor Kletz or not, but a comment was made: if you think safety is expensive, try having an accident. All right, so again, the questions: do we understand what could go wrong? Do we know what our systems are to prevent it from happening? Do we have the information to assure that these systems are working effectively? And then finally, what is your role? All right, do we understand what could go wrong? Well, International Standard 615.11, that is for use in the process industry. 615.08 is the governing standard for the manufacture of safety systems. This is for the application of those safety systems. Clause 8, hazard and risk assessment shall be carried out on the materials, process, and equipment. It shall result in, and this is just an excerpt of the list, the important ones for what we're talking about, a description of each identified hazardous event and the factors that contribute to it. Description of the likelihood and consequence of each hazard event. The determination of additional risk reduction necessary to achieve the required functional safety. The methodology for doing that typically involves layers of protection analysis. Process of evaluating the effectiveness of independent protection layers in reducing the likelihood or severity of an undesirable event to meet organizational needs. LOPA is a risk analysis tool. All right. Risk is a measure of potential economic loss, human injury, environmental insult, in terms of the frequency of the loss of or injury occurring and the magnitude of the loss or injury if it does occur. So ultimately, you look at the consequence, you look at the frequency, and that's how you come up with a risk. And there are risk criteria within operating companies. What is acceptable to them? All right, but again, the premise, understanding what can go wrong, doing the assessment. Once you know, then you have to apply the systems to prevent the events from occurring. This is extracted from a number of books in industry. It's called the LOPA onion. And just like the layers of the onion, these are protection layers that ultimately allow you to accept the given risk associated with the identified hazards. You have the process design in the middle, and then your basic control around the process design. Then you have critical alarms, automatic action, your safety system, physical protection in terms of relief devices or dikes. Then you have plant emergency response, and then community emergency response. All right, typical LOPA onion. It would be great if we could practice inherent safety in our process design. Sometimes that gets expensive, so you have to be able to put in the additional protection layers. Okay, so in the Buntsville incident, all right, again, from an operating culture, the design for your automation is essentially running within your operating limits, the yellow lines, if you will, and then you expect your safety instrumented system to intervene should your operation get outside of the yellow constraints. But their culture in their operation was to run the tank level all the way up to the alarm points. Instead of using it as a protective function, they were using it as a regulatory control function. All right. So as we do the analysis in the questions, knowing what could happen, and then putting our systems in place to prevent it from happening, this is the safety life cycle model extracted from 61511. As we mentioned, hazard and risk analysis, identification of the protection layers, defining the requirements, doing the design, ultimately installing, commissioning, validating, operating any modifications, and then ultimately decommissioning. Okay, for all safety lifecycle phases, safety planning shall take place to define the activities, criteria, techniques, measures, procedures, and the people involved. Again, implementing the safety culture, following the international standards. Ensure the safety requirements are achieved for all relevant modes in the process, includes both functional and safety integrity. So the identification of the requirements and then implementing the design. Installation and commissioning. Okay. Ensuring the integrity after installation, doing the validation, monitoring, operation, maintenance. Okay, proof testing, failure analysis, and managing the hazards during maintenance activities. Implies to the modifications. And if any changes have to be made, you're going to recycle back through the process. Do we have the information to assure that the systems are working effectively? Well, also related to the standards, talks about proof testing. What is a proof test? All right, it is a periodic test performed to detect dangerous hidden faults in your SIS so that, if necessary, a repair can restore the system to as new condition or as close as practical. All right, there's a process called verification, confirmation by examination and provision of objective evidence that the requirements have been fulfilled. And there's a note in reference to that. This is the activity of demonstrating for each phase of the relevant safety life cycle by analysis and or tests that for specific inputs, the outputs meet in all respect the objective and requirements set for that phase. All right, so as it applies to automation development, it could involve simulation, it could involve independent review of the details, but again, it's more examination. And then the last one is the validation, confirmation by examination and provision of objective evidence that the particular requirements for specific intended use are fulfilled. All right, demonstrating that the SIFs and the SIS after installation meet all of the requirements specified in the SRS in all respects. So that is typically the end-to-end test of your protective functions. Okay, remember, you get what you inspect, versus what you expect. You have to do the testing, you have to do the verification, you have to do the validation, and it has to be done over the full life cycle of your installation. As we mentioned, we don't necessarily see these incidents going away. All right, Buncefield was 2005. This was an incident that occurred almost 5 years or almost 4 years later. Cape Coast is in the Caribbean Petroleum Corporation in Puerto Rico. They were offloading gasoline from a tanker ship. They had a large above-ground storage tank. It overflowed into a secondary containment dike. Gasoline sprayed aerosol, formed a vapor cloud. And again, you have a vapor cloud, it's going to find an ignition source. Key findings: an unreliable level control and monitoring system did not provide accurate and timely information to the operator to prevent overfilling. Tanks were not equipped with an independent high-level alarm system. Tanks were not equipped with an independent automatic overfill prevention system. Again, they were lucky. No fatalities, significant damage. Okay, environmental impact. We didn't learn from what had happened 4 years earlier. All right. So back to the fourth question, what is your role? Well, again, in reference to the standards. The standards address organization resources. Persons, departments, organizations, or other units which are responsible for carrying out and reviewing each of the SIS safety lifecycle phases shall be identified and be informed of the responsibilities assigned to them. Persons, departments, or organization involved in the SIS safety lifecycle activities shall be competent to carry out the activities for which they are accountable. Now, they don't go into the definition of competent. They leave it up to the owner companies to ensure competence within and capabilities within their organization. But again, as Mark mentioned, if you don't have the expertise in-house, then partner with organizations that have that expertise. Risk evaluation, risk management. Hazards shall be identified, risk evaluated, and the necessary risk reduction determined. All right, so again, what is your role? Knowing what the risks are, doing the hazard evaluation. All right, take advantage of your knowledge of the chemistry in producing your products, but be fully aware of the potential hazards in those manufacturing facilities. Chemical Processing had an interesting article, and it was entitled, it was based on a survey, Production Takes Priority Over Safety in Some Cases. You hear multiple taglines: safety first, pound second. You know, safety is our #1 objective. There was a 2017 edition of Petrotechnique's Process Safety and Risk Management Survey of senior leaders in the fields of process safety, asset integrity, and operational risk management in hydrocarbons industry. All right, and we're trying to get insights into the state of operational risk and safety management. 61% of the respondents believe the companies do not have well-defined safety performance measures. This is 2017. This isn't 2005. This isn't 2001. 61%. 65% of the survey takers also felt that the C-suite, and this was a buzzword, the most important managers in the company, the high-level organization, they have little to no understanding of the health of process safety barriers and their importance. These are the folks at the high levels of the companies that are making the decisions on strategies. 65% feel that they don't understand process safety. Participants were asked why incidents and accidents still happen. Some of the answers that were provided: production takes priority over safety, which often leads to shortcuts and safety incidents despite corporate safety policies. Corporate lip service to process safety management policies that are not backed up with effective and efficient planned preventive maintenance. Okay, going back through that safety life cycle, doing the periodic testing, doing the verification, the validation, all the preventive maintenance associated with it. Okay. Now, I don't know which specific companies were represented in this survey. It was fairly anonymous, but again, it was in the hydrocarbons industry. It was very, very interesting results. All right. So building on the what is your role question, ask yourself, how does it apply to me and my role within the organization? Become knowledgeable. There are many conferences in industry that talk about process safety, whether it be vendor specific or whether it be standard specific. There are opportunities there. Okay, take training, read literature. Wonderful free subscription to the information published by the Chemical Safety Board. They do fantastic videos as a result of incident investigations. It's just amazing the data that comes from there. All right, Mary Kay O'Connor Center for Process Safety. Okay, be an enabler for others to learn. All right, you may have leadership responsibilities within your organization. Get some of the people reporting to you involved. Participate in standards development. I participate along with a number of panel members on the ISA S84 committee. They are always looking for people to get involved in those discussions. Emphasize the importance of effective process safety management. Unfortunately, in a lot of cases, we don't know what we don't know. So learn what you can. And again, another often used quote, those that fail to learn from history are doomed to repeat it. We have to be able to learn. So, thank you. I'll turn it back over to Mark.